Hello, welcome to the Design to Manufacturing, Bill of Material to Production session. My name is Earl Haas, the Director of Technical Sales for DELMIA Works here in North America. I'd like to start off with a little discussion about Dassault Systèmes and give us a starting point for understanding where we are and why we have this particular discussion today. Dassault Systèmes started out back in the early 80s with 3D design and actual CAM tools in the early 80s. They moved on to digital markup, and in the mid 90s, we have the acquisition of SolidWorks. This is where we started to see that mainstream CAD, but Dassault Systèmes has always been in that design and manufacturing space. They moved into PLM. They then formed DELMIA as a brand in 2000. In 2012, the introduction of the 3D Experience platform, the virtual twin in 2020, the acquisition of IQMS to form DELMIA Works in 2019. So we've gone through this whole period of time that we've built up both design and manufacturing. DELMIA, as I said, as a brand, was formed in 2000 through the acquisition of Deneb, a robotics company, robotics control systems. And over time, we've added more and more manufacturing to that DELMIA, where all the manufacturing products have come under that umbrella. The addition of Aprizo, the addition of Ortems, the addition of Quintic, and DELMIA Works have all added to this overall solution of DELMIA. Under the 3D Experience platform now, we're starting to take a look at different areas. In this particular case, we're going to focus on the manufacturing wing in DELMIA, in particular, some process engineering functionality within the 3D Experience platform. So if we take a look at just this sheer notion of bills of materials, you have bill of materials engineers working on one side of the fence, you've got CAD designers on the other side of the fence, and they may or may not be working together. How do we sync those up? You start to add in the context of model-based engineering, where we're trying to keep track of the various disciplines of engineering, whether it be requirements definitions, logistical information, engineering definition, manufacturing definitions. All of these have their different requirements for the overall model-based engineering. How do we bring those all together? Model-based engineering starts to do that, but we need to bring it together. Engineering is at the core, right? And that engineering definition, you have part numbers, you have designed components, you have purchase components, commercial items, you have software that's being created, you've got mechanical components, you've got electrical fluid, electronic software, a wider range of things that all define and come together in this engineering definition. The CAD designer is working on their tools. The BOM engineer is pulling together information for the rest of those areas. So we talk about the bill of materials on a regular basis in the context of SolidWorks. A bill of materials at its core is a list of raw materials, subassemblies, intermediate assemblies, subcomponents, parts, quantities of each needed to manufacture and produce that end product. From the engineering point of view, that's taking into account all the individual physical components that go into this product. From the manufacturing bill of materials point of view, now we're starting to say, what are those components? How do they come together? How are they fabricated? How do we get them to be a finished product? Of course, from the purchasing point of view, we need to source where do we get those components. Is it coming from raw materials? Is it coming from purchase components? How does that come together? And of course, once it's been fabricated, now how do I service that? How do I keep track of what can be replaced, what can be reused, what needs to be tossed? All right, so the engineering bomb. This guy is a generic breakdown of the components. There's usually individual parts. There might be alternate items. There might be substitute items. But at the end of the day, they come together to create that physical product. Manufacturing bomb, as I said earlier, it gives us a means of what is what are the assembly steps? What are the processes to take raw and purchased components and pull them together to create that final finished good? From an engineer's point of view, uh, they're going to create that engineering bill of material, that assembly tree that it's associated with the components and the final assembly, and put it together in the form that they need to. From the manufacturing point of view, it's not necessarily a flat tree. In this case, we've got this motorcycle that's got a lot of different steps. Maybe there are assembly steps that we're taking into account. That's where the platform gives us a tool, gives us some tools that allows us to take the engineering bill of materials and convert it into the manufacturing assembly tree. So let's have a look at what I mean uh, from the engineer's point of view. Here I have the motorcycle, this kickboxer motorcycle, and as the engineer, I've pulled this full assembly together, and I've left it in a flat assembly tree. To be sure, I've got some clear sub assemblies, uh, one for the front end here, one for the rear end, maybe even some hardware that I just wanted to pull together. I'm leveraging folders within SolidWorks to accommodate that. And naturally, because I'm working with the 3D Experience platform, I'm using the platform as a tool to keep track of and what my files are, what the revisions of my files are. I'm letting that happen up in the cloud with the 3D Experience platform. Now, if I switch gears for that, once it's on the platform, now I have this engineering content that's already up here, ready to go. I can see my full tree of that motorcycle, just like I saw it in SolidWorks. But as I said, that's for the engineering point of view. From a manufacturing point of view, I've started to pull together a manufacturing subassembly. So I've got the front end assembly already in place. I might have a hardware kit that represents just the hardware, so I can kit up the hardware that I'm going to need to assemble that front end assembly. Uh, I might have that front wheel assembly, and within that wheel assembly, I might obtain a front caliper assembly. I'll get the spindle. As I said, get all of the information, all the components that are necessary that are associated with that particular assembly. So I now have some different assembly steps that are in place from the manufacturing point of view, and it's independent of the engineering tree. Okay, what did we just see? I showed you the process of the manufacturing assembly. I showed you some provided parts. We talked about the hardware kit, that manufacturing kit, the kit of parts that I need to pull together for a given assembly step. That would be my manufacturing kit or my hardware kit. I didn't talk about the manufactured material. That would be your raw material that perhaps it's a stock of aluminum billet, and we're going to mill it into one of the components for that front end assembly. So that would be a manufactured material. We take raw material and the finished component, bring it together. That would be part of my manufactured assembly. So let's have a look at the specific steps. We're going to have our core assembly from the engineering point of view. We'll put that into manufacturing items management. We'll see that listed in the tree, and then we'll create manufacturing assembly scopes, and we'll create the connections between the two. We'll create subassemblies as we need to for the assembly process, and define the scope for that. So let's have a look at how that works. All right, rather than looking at the extent of that motorcycle, I'm going to take a subassembly of this leg here, and in particular, we'll look at the calf of this leg. So as we look at it in the tree, it's a relatively simple leg, and again, it's available to us up on the platform. So let me switch over to the platform and look for that leg, and so we'll go ahead and grab that guy and pull him uh, into the tree. So what we're seeing here now is the same assembly tree of that calf, and we'll go ahead and create a manufacturing assembly for that uh, calf to get us started. All right, so we now have this in place. We've got the full calf and selected, and to be sure, from a manufacturing point of view, I might just assemble all of this all at once. But what I'm rather do is just break it down as if we were building it in multiple steps. So let's say we're going to work on uh, just the left-hand side, for example. So we'll go ahead and create uh, a left-hand side version of this, and that left-hand would be, say, the left side of this guy, and we'll go ahead and find the side plate of that as well. So now I have, if I look at those two, we've got the left-hand side and the components for the left-hand side in place. So let's continue this path. We'll go ahead and grab the various hardware for that. I always find the wrong ones. So we'll grab the hardware for that left side. So I've built up the subassembly for the left-hand side, and we'll do the same thing for the right-hand side. Grab the right plate. And of course, I moved those into the wrong location, so let's go ahead and move them into this guy here. So we'll move them. So we get the opportunity to decide, are we going to create new instances, additional instances, or if we're just going to move those. So I'm going to take advantage of moving those around and restructure it. So again, the engineer pulled together the assembly tree on this side. I'm building up the tree that represents the assembly process. So that's independent of what the engineer's working with in this regard. So we'll go ahead and grab each of the flathead cap screws, add those in. And as it's building all of this up, I go through and look at some of the tools that we have. We can actually see which components we've actually taken into account. So I have a visual cue So this is the top level assembly, but then I've taken into account each of these separate items in my tree. So I know that I have additional work to be done on these other aspects. So what I'm going to go ahead and go do is go grab uh, these other items. We'll just drag them into the top level here. So now I've got the two sub-assemblies, the left and the right-hand side, and the main parts of the assembly. Now I could go ahead and create and bring in all of the remaining hardware. So this gives me now the full tree that I have that I'm looking for my overall system. Now it's ready for assembly. All right, so we've created that content. So now what happens? We've built up that assembly tree. We've sent it off to manufacturing. Uh, but now we might have that scenario where we're going to follow the process as we now make changes to our assembly. So the first step is to modify that structure, and we would do that in the context of what our CAD system. The platform gives us a tool to do some revisions. We'll create a revision and we'll replace that with an example. So let's have a look at how that works. All right, let's head back over to SOLIDWORKS then. And again, we're working with this CAF, and at the moment we're going to make some changes. So let's start off by we're just focusing on the right-hand side of this guy. We'll go ahead and let's create a new revision for the side plate here, and let's go ahead and create another for again this particular side plate. So we'll just go ahead and add a couple of revisions to that. And so now it's listed as being out of date because there's a newer revision in the system. So if we come back into here, we can go ahead and replace with that revision, and we can actually see which what revisions are out there. We've got the original, we've got the next one, and we'll go ahead and grab that latest revision, get it replaced. So naturally, if there was geometry changes to it, then we would see it there. But in this particular case, we're not. So let's go ahead and replace the second one. And so now we've got the updated versions of both this guy and this guy. And of course, because it's the same component, that's the other side has been updated as well. So now we've updated the system for the different versions. All right, so what we just saw was that assembly tree, and we've just created a simple revision in in SolidWorks. We could do it with wherever we're working, whether it be in XDesign or SolidWorks or any other CAD system that's connected to the platform. So the next step is to do an MBOM impact analysis. Find out what's been changed between the engineering bill of materials and the manufacturing bill of materials. And we'll do this through the manufacturing items management tools, or MFN. And we'll see that in the context of that product assembly. We'll see what's changed and what needs, if there's any tools that parts or assemblies or the tree that we need to sort out. The next step of that process will be to generate a change action for that process. So we will go through and use some of the Innovia tools to create a revision, effectively an ECO for our MBOM, a change order for that. So let's go ahead and create a change action for our assembly tree as we change it. All right, let's head back over to the platform. And uh, now that we have items in place, let's let's go ahead and have a look at what have we done with this guy. Now we start to see that the components uh, that we've made changes to are now no longer the last revision. We can see that these things are out of date. So what we'll go ahead and do then is once we've updated our view of this guy, let's go ahead and create a change action. And a change action is simply a process by which we're creating an engineering change order. In this case, it could have been done by a leader. It could be done by the engineer. Uh, we're just going to go in this case. We're just going to update our MBOM. So we'll update. All right. So we'll go ahead and save that guy. We could give it a due date, a severity level, and so on. So as we start to look at what does that mean here, we can apply it to whomever is interested in it on our team, whomever has activities associated with it. In this case, that's going to be myself. I'll be the assignee, I'll be the approver, and so on. So, heck, I could be the informed user if if I was interested, if I was uh, someone who needed to know when something changed, but not necessarily uh, know information about it at that point. So now that we've created that, we've done the work. Let's set that into being in work. So we've gone from a place where we've assigned the that change action, uh, and now it's we're switching gears to a point where it's now something that perhaps we would apply it um, to the actual activity. And so we'll go ahead and apply it to um, the manufacturing items management. So we've got some changes that need to occur to that. So at this point now, uh, we've we've created and defined the change action that needs to occur here. All right, so we've created that change action. Our next step is to go through and update the MBOM. So we need to update the changes, make changes to both the MBOM and get everything up to date. So the first step is to find out what's changed. We'll make sure that the engineering side is up to date. So we'll go ahead and do that. The next step is to make sure that the MBOM is up to date. So what it's going to do is it's going to make sure that we can connect those two together, make sure that we have the right versions of each of the components, and it's giving us the tools for understanding what we need to do. All right, so let's go ahead and update, refresh our screen here with the latest and greatest version. And so we have the updated version of our tree, and let's go back into our BI tools, and we see that uh, that the components that we've changed are now updated with the content that we're working with. So what we can do here now is to go through and actually go through and say, all right, which ones have been updated? Let's go ahead and update the items based on the changes. And so this is giving us the opportunity to update these revisions as we like. So we can go ahead and do this. For example, we can do this automatically as we need to. And so that guy's going to go ahead and update the 17838. If we look over the 17 838, that's been updated to the new revision, and it has created a new revision based on the model. So if I take a look at the revision, it's pointing to the appropriate revision of that component. We see that I still have some work to be done in this case here on the 17833R. So we can go in and actually take advantage of perhaps creating a new revision of that component. So it'll add a new revision to this guy, and we can then go ahead and um, update that revision into the system. So we're on our way with respect to the components. So now if I look at this tree here, now we should see the updated versions. We can go ahead and hide that extra um, item in the tree. So now that we've created that, we are done with updating our MBOM. All right, so we've just created that. We now know what the change has been done. We can go ahead and release those changes. So now we've made the changes. We can go back to our change action and actually indicate that it's been done within the system. So we can change the the life cycle uh, of our change action and set our MBOM and to the next step in the life cycle. And so if there were other people that are assigned to that change action, they'll get notified of the changes that have occurred. So, and then we'll go ahead and release it to set it into an approval state. Right, so now we have the engineering BOM is up to date in our manufacturing items management. We've updated our MBOM to match up with our EBOM. So now we're in a state where we've completed our work for our change actions. So at the moment, the maturity level for all of our components for the MBOM are set to work. So because we're working on this MBOM, we're going to go ahead and change the maturity level from the in-work state to one of a couple of different places. So right now we'll just go ahead and advance it forward to the frozen state. So we're going to the next step. We're done working with this MBOM, and now it's in a state that we can go ahead and complete our change action. So now that everything is frozen, let's now have a look at that change action. We can set up its next step to be in approved state, and it's now going to apply all those changes, and it's going to keep track of those. So now it's all been assigned, and you see that because I am listed as the approver, we saw that I have now received a notification that this change action has occurred. So I can sort out what the next step is. I can go into the approval state for my components. So we're off and running to the next step in our process. All right, so we've gone through that entire process. We've gone through products. We've taken that product structure. We built up the MBOM from the engineering BOM. We've gone through, saw how we might go through the changes for the product structure. How do we make our updates? How do we know when we need to make updates? What components in our MBOM do we need to update so that we have the right revisions? And we've released that and notified all of our colleagues that need to know about those changes. So let's have a look at a possible scenario where this fits in. So now we've created all of this. We've created the MBOM. So we've created the MBOM, and we're now working in the context of DELMIA Works, where we're actually out manufacturing this. So in DELMIA Works, we've pushed this MBOM out to DELMIA Works. And now we're actually building this components, and we now have the tools available to us to keep this information up to date based on our change actions, based on the engineering BOM. We know what needs to be updated. We know how the MBOM should work, and the process is pulled together. We have a nice clean process following our bill of manufacture from engineering through to production.